Good morning. Today I'm going to give an investor presentation for the Ladenburg conference. And my next slide is a safe harbor slide. The presentation we're going to give is LWLG. And you can see from this slide, we are really excited with the progress we've achieved in the last 12 months. And we're excited about the future. And so one of the things we did just over a year ago was ring the bell at the NASDAQ, where we uplisted organically from the OTC to the NASDAQ markets. And September 2021, you can see there's some very happy people in this slide, also excited. In fact, NASDAQ just sent us a 1-year happy anniversary back in September. So we've been on the NASDAQ over a year now, and that's been exciting times. Being on NASDAQ has really allowed us to engage with the institutionals and the banks and really position ourselves for volume scale. So 4 takeaways from my talk. As you can see from this slide, there's 4 bullets. We have unique polymers. These are materials that are similar to what you would find in organic LEDs or OLEDs, the type of displays that you look at even right now. Our polymers are slightly different, and I'll go into that. Our technology is ultra fast and ultra low power when it comes to switching and modulating light and saving power consumption. And we as a company are positioned to have polymers that you can become ubiquitous, just like you've seen in the OLED types of polymers in different types of displays across the country and across the world. And our polymers, this last point, are foundry compatible, which means that we can manufacture them in volume, in scale, using semiconductor foundries. So let's get to the outline of the talk. I'm going to give a little bit about what we do, some of the market dynamics, go into some of our core competencies, our business strategy, our investor relations and leadership with patents, and then I'll summarize. So what do? We solve the problem for the fiber communications market, the internet, if you like, for at least a decade. We create materials that are polymers that are unique. And the interesting thing about our materials is they switch light very, very quickly. And when you switch light very, very quickly, it allows you to send a lot more data down the internet. And that is great because if you're trying to get high bandwidth data to your displays, to your computers at home, you actually really would like that, so you don't have to turn the display off because of bad signals. We've all experienced that in the last couple of years. Our materials, you can see from the 3rd point, are polymers, just like you would use in OLEDs. The OLED LEDs, or the organic LEDs, are polymers that actually send out light, red, green, blue, so you can see the displays. Our polymers switch light, they switch it. So they don't send out light, so there's a different chemical composition, but they do switch light really quickly. And the devices that utilize our polymers are called modulators. A modulator is a device that modulates or switches the light. And our polymers do this very quickly and very low power. They're very small, and I'll show you some photographs to show how small they are. And we believe the performance of our modulators are transformational. They are going to impact the internet positively for higher bandwidth, lower power for at least the next 10 years. And lastly, we can integrate other devices with our polymers, so they're quite versatile. So in terms of the market dynamics, this slide is titled The Holy Grail. It is a roadmap graph. You can see years on the horizontal. You can see speed of traffic on the vertical. It's done by the Ethernet Alliance, which is an organization that really plots the performance of link speeds over time. And you can see they've indicated the holy grail of increasing speeds over the next decade is actually single lane. And we have a technology to actually access single lane. And so we have a technology to really address the high performance that the Ethernet Alliance standards are actually proposing. And so that means that we have the opportunity to actually address the Holy Grail challenge, which is really exciting. And the basis of this is faster optics. And so when we think about the whole market environment that's happening out there with data centers and different types of telecommunication centers that deal with the internet. We can look at this graph and just look at those big square red boxes. This is the electricity usage of data centers from 2015 going out to 2013, 2030. And you can see the increase in electricity is nearly exponential. It's increasing at a horrific rate. And that's shown by that red arrow saying power. We can also see from this graph, from the blue boxes, that the traffic, that's the amount of data on the internet, is also increasing pretty heavily too. And this is a major challenge for the data centers and service providers. And so power is growing exponentially, increased traffic levels is growing quickly too. It is the Achilles heel of the industry, and it needs to be addressed. And so when we look at addressing these markets, you can see, this is the chart we've plotted, and you can see there's areas in green and there's areas in bluey gray. The green areas are the ones we are focusing on right now for our optical polymer modulator technology that goes faster in terms of switching light and lower power. And you can see from the left-hand side in the green, fiber communications, high performance computing, data center interconnects, 5G systems. These are all optical fiber-based applications where the internet is involved. And so this is our focus, and you can see by the red box that these are huge opportunities in terms of total available markets. We can also see below the red box that in the gray bluey areas, there's a number of other horizontals that represent other market applications that are also really attractive too. And we can see these markets as an additional bonus, if you like, for our technology. But we are focusing on the green areas right now. And so in terms of our core competencies, the polymer advantages are clearly, I've just indicated, we're the 2 to 3x faster in terms of switching light compared to semiconductor modulators today. We're naturally very low power consuming. We can operate less than a volt. This is actually an order of magnitude lower in power consumption, depending on the device architectural design, and which has a huge impact with the internet and the optical communications community. Our technology is easily fabricated using silicon foundries. Process is standard. It doesn't require special toolkits. We have security of supply. We design our own materials here in Denver, Colorado, and the materials are sourced directly from LWLG here in Denver. And we are a low-cost addition to other integrated photonics platforms, which is where the industry is going today. And so if you look at this slide, the polymers are definitely unique in their properties. And in this year, we've shown some fabrication of our modulators using foundries. And we've actually transferred PDKs to the foundries, and we've received working modulators, and we're testing and evaluating those modulators as we speak. And so this has been a great year for us with a successful PDK implementation with our foundry partners. And we can see from this next slide, once you have the working devices, what you need to have is really small modulators. And so the smaller the modulators, the more you can get into a box or a transceiver or a package. So size really matters. You can see from this particular slide, a 1x8 slot array. The modulators themselves are 1 millimeter long by about a 0.5 millimeter wide. So the total surface area is 1 by 9 millimeters. And you can compare that to a recent competitor on the left-hand side, where they have 8 modulators in a size of 9 by 15 millimeters. Within that size, 9 by 15 millimeters, we can put in up to 120 modulators depending on the design, which means we can actually increase the amount of traffic going through our technology in terms of the package and the transceivers. So this is really high performance using small size, high speed, low power technology. And in fact, where does the technology go? The technology goes into boxes that are used on the internet called transceivers. I've showed you schematically what these look like at the end of the green arrows. And these boxes, these transceivers fit into the internet equipment called switches and routers. And you find that in the data centers. And so we have essentially the polymer engines for pluggable transceivers, which is really exciting because we can change the way the transceivers perform, the routers and the switches perform from the high performance engines that are composed of our polymers. So what's our business strategy? Business strategy is threefold. Clearly, we can make and sell components. We also, because we have a very strong patent portfolio, is we'll be able to license polymer materials and tech transfer those materials to foundries. And so items number 2 and 3 are in progress as we speak. And so to become a leader in the engineering and manufacturing of electro-optic organic polymers, we feel the business strategy has to combine selling components, licensing our technology, which is unique, and making sure that foundries have access to our PDKs. And this slide here shows you our very strong patent portfolio. There's over 70 patents and patent applications. In fact, as of this morning, we put out a press release. We acquired the IP from a UK company called Chromosol. You can see that under the acquiring box there. And this allows us technologies such as atomic layer deposition and different types of organic devices, which puts our patent portfolio even stronger as we move into commercial volume manufacturing. And so we have to partner for success. And so we are partnering with foundries, we're partnering with packaging companies, and we're partnering with module transceiver partners to position ourselves for high volume production. In 2022, we have partnered to qualify polymer PDKs with foundries. That's the recipes. And we are continuing technology evaluation and feedback. And we're in contact with the foundries on a daily basis. This is really exciting. And in addition to partnering, we're licensing and tech transferring our technology. And so partnering is a big part of our business strategy going forward. And so scaling with the foundries is really important. In this slide here, I'm given some timelines under the comments column on the right-hand side, where we can see for the two major device platforms, the Polymer Slot and the Polymer Plus, we're using foundries both in North America and Europe. These are on silicon wafers. These foundries have existing PDKs with photonic integrated circuits or PICs. And we have our polymer PDK operational in the foundries, both for the slots and the Polymer Plus, with some of our expected updates of future results in 2023 given on the right-hand side. And so our activities with the partner foundries continues to increase, and this is really exciting for us. And in fact, our potential customers are all levels of the value chain. So we actually are engaged with every level here, from optical component suppliers to high-speed optics manufacturers to optical network and equipment manufacturers, as well as the internet service providers and end users. And so we can enter the market in any one of these levels, from foundries on the left-hand side to directly to end users on the right-hand side. And we do have to remember that the end users on the right-hand side, many of these folks are actually vertically integrated and so have a lot of the technologies within their grasp, and also understand their gaps in their performance and power consumption, which is where we are engaged with them. And so our technology roadmap with the timelines really aligns to where our technology platform is, from our unique chemistry on the left-hand side in that in that horizontal, unique chip design, unique high performance design of our materials and devices, as well as unique polymer PIC platforms. And so our technology roadmap, it emphasizes our unique value to the industry, and it is ideally aligned with where the technology needs are today and over the next 10 years. And so the business roadmap with our timelines, as you can see, as we go from 2022, which has been a fabulous year for us, into 2023, we're going from customer interactions, testing, evaluation, partnering with foundries, to customer qualification and design verification. And we are doing a lot of reliability and testing and evaluation of our materials and devices in-house. And so this slide here, as you can see, is a third-party review of our materials that we actually supplied to a company called Solorix that works in conjunction with Karlsruhe Institute of Technology, which is a university in Germany. And they took our materials and put it into their slot modulated devices. And as you can see from this slide, we actually achieved between us world record performance for polymer-based silicon slot modulators. This was actually a peer-reviewed paper that went into an international conference called ECOC 2022 in September earlier this year as a post-deadline paper. But what this does show is that it doesn't matter on the device design. The quality of our polymer materials can be applied to different types of devices and achieve world record performance. And this performance is not only in terms of speed and low power, but also in reliability and stability, as you can see with some of the graphs on the top left-hand side. And this was also augmented with another paper that was a post-deadline paper at the same conference with a different company called Polariton. And in this paper, we also achieved with our materials, and our materials are depicted in the yellow box in the upper left-hand side of the graphs in this slide, as our electro-optic polymers were used in plasmonic slot modulators, which is Polariton's slot modulator design, and also achieved world record performance. And this is third-party review with a different device structure than ourselves to show the performance of our material is truly world-class. And this is really, really exciting. So this is really a sunrise opportunity for polymers vis-a-vis the competition, which is semiconductor modulators. And I've said this before, I see semiconductor modulators as being a sunset technology, and we have the sunrise opportunity. So our leadership in our company, and we have an incredible board of directors. As you can see from the 6 board of directors, we have a very, very experienced VP of engineering, Dr. John Ziskind. And you can see by the background of everybody on this board, we have deep technical and business experience in the technology space. And this is really exciting for us. And we've augmented our experience management and board with an advisory board, both with chemistry experts as well as device and photonics experts at senior levels, even somebody who really understands organic LEDs, what it takes to make organic LEDs or OLEDs into commercial displays, just like the displays we're looking at right now. So I have a world-class advisory board making sure the technology vectors and direction we're going is ideal for commercial volume for our polymer technology. And so I will summarize this presentation with some of the major aspects of what Lightwave Logic brings to the business and commercial community, from material science that is unique to fabrication to testing to really high-speed design and packaging, a powerful patent portfolio that has been improved with the acquisition of Chromosol that we put out a press release this morning that gives us even stronger position with polymer materials and some of the processes of atomic layer deposition, which we have already developed ourselves in 2022, but gives us extra weight in that area, which is really exciting. Huge market opportunities and solving key internet Achilles heels, scaling with silicon foundries. I mean, this is something that is really exciting for us. And so if we go back to the 4 takeaways we said at the start of this presentation, our polymers are unique. Those polymers allow ultra-fast optical switching and ultra-low power operation, which is exactly what the internet providers need in their switches and routers as they route and switch the traffic over the internet. And also we are positioned with our partners, with our foundries so that our polymers become ubiquitous. We want our polymers to become everywhere, not only in the fiber optic communications market, but in other market applications too. And lastly, which is really critical going forward, is our polymers are foundry compatible. We have to make sure our polymers can be run in the big foundries in volume at scale. And this is what we've been working on. And this has been successful this year, as we have shown that we have working devices, and those working devices are now going through extensive reliability qualifications. So this has been really exciting for us. And so I want to thank you for this presentation. And to summarize this in 3 words, we've unparalleled progress this year. We have a technology that is truly unique. It's high performing. And as you can see, we want our technology not to be a technology for a few applications, but we want it to be ubiquitous. We want it to be everywhere. And this is how we have positioned the company so we can scale in volume. Thank you, and very much appreciated you listening. Thank you very much.